All right, should we start? Questions before we start? Or questions? We're here for questions, so do you have questions? And people online, if you have questions, go and type them in the chat and Rudy will monitor the chat. Yeah.
So today are you going to go over the practice or not?
Yeah, I'll go over the terms. So, I've given you terms. I've also gone through online and I put together I basically just consolidated all the slides and put those together. And then you have a practice exam. So I figured that I could go over any terms that you want to go over and then go over the practice exam. Does that sound good? Should we start with the terms? Okay. Any questions about the format of the tests? Anything? Yeah. Uh-huh. Pretty close. Yeah. Other questions? All right. Terms. Any of these terms you want me to go over? Yeah. Actually, you don't have to worry about reliability. It was in the book, but I didn't cover in class. So here, we'll take reliability off of there. We'll do that after the midterm. So reliability is gone. Yeah. That was easy. I think all the rest of them though we covered, right? Sure. So inductive, what's the difference between inductive and deductive? Yeah. That's right. So inductive is when you make generalizations based on your observations, and deductive is when you make when you use your reasoning. So, for example, pen drops to the table, right? So next time I think the pen is going to drop to the table. Is that inductive or deductive? Inductive. Mm-hmm. I think the pen's going to drop the table. So I think that if I take this speaker and drop it, it will also drop to the table. Inductive or deductive? Deductive, right? Because I haven't dropped the speaker yet. Speaker may fly up into the air, but I'm surmising based upon my inductive rule that this thing will also drop to the table. That's deductive. So when you do theory, when you have a theory and you make predictions from theory, is that deductive or inductive? So if you have a theory and then you make predictions based on your theory, are you doing deductive or inductive reasoning? Which one? Deductive, right? Because you're having a theory and you're not using observation per se, you have theory. So that's why all theory is basically deductive. When you come up with predictions from theories, it's deductive reasoning. Any other terms on this? The different, yeah. Positivism, sure. So anyone know what positivism is? So positivism is basically, it's the basic philosophy. So, there's a number of terms here, right? So there's positivism, paradigm shift, hypodeductive method. These things are all kind of just deal with the process of how we do science. So that the hypodeductive method suggests that, that what you do is you come up with a research question, then you state as a null hypothesis, and then you do a test, and you're testing to see whether or not you can reject the null hypothesis. And you make it a tough test because you make it a tough test, right? In fact, what percent, if your null hypothesis was true and there was no relationship between, your independent and dependent variables, what percentage of time would you find do a study to find a relationship between your independent variables and dependent variables? So, if I have factor 1 leads to factor 2. if I say sleep leads to better grades. What's my dependent, what's my independent variable? Sleep is the independent, correct? And then GPA is your dependent variable. So let's say if you had two groups, you have a high sleep group. So you have a high sleep group and a low sleep group, right? And then you look at their GPA. So let's say the GPA of the high sleep group is 3.3 and the low is 2.7, like that. So it looks like that, right? So what's your null hypothesis? So if you think that sleep leads to higher GPA, what's your null hypothesis? Yeah, sleep is not related. Sleep is not related to having higher sleep is not related to a higher GPA. Does not lead to a higher GPA. Right. So if you say that higher sleep does not lead to higher GPA, and what you're saying is that there's no difference between these two groups, right? And so the fact that you get a different number, does that mean that there's a significant difference? Well, what you're really testing is you're saying, okay, so you're saying that I am hypothesizing that the true mean is 2.7, right? For the GPA. And that if I find a GPA of 3.3 here, then do I think it's consistent with that? With that, you know, with the number, with this coming from a distribution where the true mean is 2.7. Right, so that's the hypodeductive method, is you set it up that way. You set it up so you say, well, okay, my null hypothesis is that there's no difference between these groups. And so I'm looking to see, you know, what's the likelihood that I would get a mean of 3.3 from a sample if the true mean was 2.7. Okay, nod your head that you understand this, or shake your head that you don't understand this. You have to either nod or shake. You can't hold still. Ready? I'm gonna count 3. 1, 2, 3. Couple nods, shakes or nods, which ones? Oh, you did a bob. A bob is not a shake or a nod. Okay. So the idea is that, you know, when you do a hypothesis test, what you're doing is you're looking at, you say, well, okay, we're going to get a sample. So we get our first sample and it turns out to be 2.7. Then we get a second sample, and we get a third sample and everything else, right? And so if we want to say, well, what does the distribution look like from that? The distribution looks like this, like a nice bell curve of all the sample means. So therefore, I go and I get another sample, and that sample has a mean of 3.3. So the question is that sample, is that consistent with coming from a distribution where the true mean was 2.7? That's the question. And so what you do when you set that thing up is you start by saying, well, your null hypothesis, your null is that, you know, sleep not related to GPA, or more specifically, that higher sleep. Now I have to be more specific than that. That the group with more sleep does not have a higher GPA than the group with low sleep, right? That's my null hypothesis. So I'm setting this thing up. I'm saying, okay, so I'm going to just start by assuming that this 3.3 comes from a distribution where the true mean is 2.7. And so then I go through and I then see, well, what's the likelihood that this thing comes from that distribution? And to do that, I set up my significance level. So what significance level should I use? Should be on your forehead. P less than 0.05, right? So what that means is I'm setting up like little, I'm sort of saying, okay, I'm going to find this number here. I'll call this X1, and number 2, X2. And I'm going to see if I'll see if 3.3 lies outside of X2, then I'll say, oh, it's different. you know, that this did not, I'll reject my null hypothesis. If it lies inside of this, then I'll accept my null hypothesis to say that there's sleep doesn't matter. Right, so that's the basic idea behind the hypodeductive method. And so the fact it's a tough test, it's a tough test because if this was really true, if sleep didn't matter, right? If high sleep group didn't have a higher GPA than low sleep group, then could you get a mean of 3.3 if it truly came from a distribution where the true mean was 2.7? Could you get that? Like if I said, people who wear brown shoes have higher GPAs than people who wear black shoes, right? And I go and I test everyone, and I find now the brown shoes people have a GPA of 2.7. And now I'm going to test all the black shoes people. Now, if there's really no difference in terms of shoe coloring, in terms of determining your GPA, could I get a sample mean of 3.3 for my black shoes group if the true mean was 2.7? Yes. Is it likely? Well, no. It's less than 1 out of every 20, less than 5% of the time, right? So you could get it, but it's very unlikely. So that's what the P less than 0.05 means, is it means you could end up with a mean of 3.3, but it's very unlikely. Doesn't mean that doesn't mean that your null hypothesis is that your hypothesis is true. You haven't proven anything, because next time you could go get another sample of black shoed people, and their mean is 2.3, right? And then you get another mean of black shoed people, and it could be 2.6. And so you could just sort of, you know, because it could be is that it's all coming from this same distribution here. Good. Okay, so that's the hypodeductive method. What's the difference between causality and correlation? What's the difference between causality and correlation? Because, you know, we have these two terms here, right? Correlation and causality. What's the difference in correlation and causality? Yeah.
Causation is like a known variable that it does object, and then correlation is multiple variables that are like interacting with each other. So you can't really say that it is the cause of whatever it is. You can say that's linked, but it's not.
Let's see. Let me think of an example. Example of correlation, it's not causation. It's an example, a good example. Correlation, that's not causation.
Maybe the
There's
ice
more-
cream and
There's more parking spaces available on weekends than weekdays on campus. Okay. So would you say that weekends cause lower parking spaces? What causes lower parking spaces? Yeah, when there's classes, right? So having classes causes lower parking spaces. So it's not like there's something about a Saturday, I mean the day of a Saturday, that means that suddenly parking just frees up. It's that there are no classes on Saturday, so you don't have as many parking. And so if you were to go through and to look at parking on campus, you would say that there was more parking, I mean, that the causality goes classes leads to less parking, and weekends is associated with less classes. So therefore, weekends is correlated with parking, but it's not the causal factor. It's like if you came here on a Saturday in July and then looked on a Monday in July, you would find in both cases there was less parking on campus, right? And it's not because suddenly the Mondays in the summer are different in terms of the causality. It's that because it's classes. Classes is the thing that causes it. So things can be correlated, but not causation. Right, so that's And then also sometimes you don't know which way the causation goes. As that, things can be correlated, but you don't know whether two things are. So for example, see what's a good example. Am I grumpy because I didn't sleep much last night? Or did I not sleep much last night because I'm grumpy? Right? Because you can think of an argument either way. And I slept fine last night that way. But I am kind of grumpy this morning though, because we have my son's dogs. We've had my son's dog. He sat there and he said, "Hey, would you watch our dogs for us?" And I thought, sure, love to watch your dogs. And so it's usually like 3 days, 4 days. It's been 2 weeks, and he's got big dogs. And one of them this morning, there's a young puppy that's about, it's about this big. It's a big hound dog. And this morning I let it out and it takes off after a deer. And it just runs. And I have a collar on it so I can check where it's GPS. And I can see it's just running all around. And so I had to, I had to come here for class. And so instead, I'm out there running after this dog, trying to find where this dog is going as it's running all over the mountain. So, and it could hear me. It just didn't want to come back. So not very happy with the dog this morning. It has nothing to do with sleep, just not very happy with the dog this morning. So my grumpiness and sleep, you don't know which is the causality factor, right? Because I could have been grumpy when I went to bed and therefore I didn't sleep well. Or it could have been that I didn't sleep well, and so therefore I'm grumpy. You don't know. So when you don't know the causality, then you can say they're correlated, but you can't necessarily say what direction the causality goes. How do we usually go through and kind of make it, figure out the direction we think the causality goes? We use theory or deduction, right? So like we usually have a theory that we sort of think, oh, well, I think that his grumpiness leads to his not sleeping rather than his not sleeping leads to his grumpiness. So you have a theory about that. And, your theory may be right or wrong, but the point is that that's how you get, when you set these things up like that, that's how you set it up. But if you don't have a theory, then the cautious thing to do is just to say, well, it's just a correlation, but without some type of theoretical causation. Okay. Any other terms here? I'm sorry for that, Brad. Yes. Second last one, the Cochrane review. Yeah, so Cochrane review and meta-analysis. Whoops, sorry, come back. These are all different things that different types of. These are Cochrane reviews and meta-analysis are different types of literature searches that you can do. So a Cochrane review is a more formal type of meta-analysis. They do Cochrane reviews a lot when they do clinical guidelines. So, like if you ever if you go and get an MPH course, oftentimes in MPH courses they teach how to do Cochrane reviews. It's a very specific type, a very thorough type of literature review. And then the meta-analysis is where you take a whole bunch of different type of studies, and then you do basically a study of the studies. So you take all the results and you pool it. Like Rudy just got done with a meta-analysis. So in this case, Rudy got a whole bunch of data on different types of health scores for different kind of chronic conditions and got from studies, put it all together, and then did analysis of all the studies from the analyses. That's a meta-analysis. Any other questions from yeah. The ethics of deception in research. Yeah. So this gets to the question about, well, when can you deceive people in research? So, Rudy, you talked about this Tuskegee experiment, right? In ethics, right? That's a case where people were deceived and it was unethical, right? On the other hand, psychology experiments oftentimes deceive people. Like, you'll come in and they'll say, oh, well, I think I told you about when I was involved in research with kids putting on beads, right? And I told them they won or lost. That was deception. So sometimes, deception in research is not necessarily something you can't do, but yet you can only do it in very specific circumstances. Well, what IRB says is that do the risks and the benefits outweigh the risks? That's the criteria that IRB uses. So like I had a friend in graduate school who was fearful of spiders. And so she responded to it. I mean, like really fearful of spiders. And she responded to it, to be in a psychology study to sort of help you deal with your fear of spiders. That's what they, sort of said. So she signed up, went off to the study, and what they did is they basically just showed her pictures of spiders, right? And then they gave her a questionnaire. And then at the end of it, they said, oh, well, this was not really a study about to help you deal with your fear of spiders. This was just that we wanted to get an emotional state that was highly aroused. So we thought people who are afraid of spiders can be really, really aroused, really afraid of spiders. So therefore put you in a high emotional state. Okay? So that's unethical because in this case, the benefits, this guy just wanted to give a questionnaire where he just wanted people to be in some type of aroused state, was not, did not outweigh the cost to this person who was purely terrified of this entire thing. So, and there's no kind of there's no hard and fast rule here. Ethics committees just they have to make a call about whether or not it's worth it or not. Yeah.
Sorry.
No, I'm done.
Positivism and paradigm.
Positive in which one? Positivism and paradigm shift. Okay, so that's why I guess I never answered positivism. So positivism is just the belief that, that this whole hypodeductive method that we went through is that you can do it that way. So positivism means that the world can be broken down into rules and that research can then go through and can discover those rules. So positivism is what sort of underlies all of scientific method because it sort of assumes that there are some type of rules that govern the universe and that we can discover what those rules are. Whereas like, if you're someone who believes in that the Egyptian gods control everything, then, you're not going to engage in positivism because you think that Iris controls everything about that happens in our daily life and Ra controls these things and stuff. And so there's no kind of rules to discover under that type of belief domain. So that's positivism, that you believe the world is basically somewhat orderly. And in paradigm shift, this refers to when you have a way that you're viewing the world, right? Your theoretical, a paradigm, think of a paradigm as like a meta theory, right? So a theory is like something that's very concrete, and a paradigm is a meta one. And so a meta type of I think the example I gave was the Earth. I mean, Earth was the center of the universe, right? That's a paradigm because you have this view that God created Earth. Well, Catholics have this view that Catholic Church had this view that God created Earth or God created everything for men. Sorry, not women, but for men, and so therefore the Earth was the center, and everything revolved around the Earth, because it was men, and that and all animals and everything else were there for men to do with what they want. So that's a paradigm. And then what happened is that when they come through and sort of say, oh, the Renaissance hits, is that they change that paradigm. And then suddenly no longer is the Earth the center of the universe, but now rather the sun is the center, and so et cetera. So that's a paradigm shift. And so what happens when you have a paradigm shift is that then you start to think of new types of theories and new types of ways to test. It doesn't necessarily mean that that you can't get results that were consistent with the old paradigm. It's just that people look at it a different way now. Okay, any other questions on any other terms? Yeah. Yeah. So how would what do I mean by operationalize? Well, like in this case, you want to do sleep and GPA. How would you operationalize sleep? So operationalize means how do you actually define it, right? How are you going to measure and define it? So in this case, how are you going to operationalize what sleep means? Well, you could do number of hours you slept last night. You could do overall quality of sleep, some type of measure of quality of sleep. You could do sleep that goes along with the average number of nights you slept, I mean, average number of hours you slept per night over a period of time, whatever it is. But what you're doing is you're operationalizing what it means to how you can measure sleep. For GPA, how would you measure GPA? Well, you could measure it by your test scores in a given semester, your overall GPA, etc. But operationalize means how do you actually go through and define what exactly you're looking for? Okay, other terms? All right. So the rest of this then just goes through and just kind of gives you some of the, oh, come on, gives you some of the things that, you know, from the chapters that were consistent with what we've covered. So, you know, like I said, you know, for the most part, things that we covered in class that are in the book that we covered in class are the things to concentrate on. I don't think I asked you anything that's in the book that we didn't cover in class. So I think you can just concentrate on things that we covered in class that are also in the book. And sometimes the book goes beyond what I talked about. So therefore, you know, do kind of just realize that there are different, even though I may talk about sampling, and there's some things the book talks about with sampling that go beyond me, you're still responsible for that. Okay, shall we do the practice test? Okay. So this is the type of questions I'll ask you in the first part of the exam. Older people who are Democrats are more likely to get a booster shot for COVID-19. What are the independent and dependent variables in this statement? So what's the independent dependent variable? Independence of Democrats. That's right. And you know that because, I mean, how would you explain why that is? You might want to try and use this. The factor one and factor two thing. I mean, we'll put this way, if you use the factor one and factor two kind of explanation, I would think that's fine. So in this case, you could say your political party influence leads to whether or not you're going to get a booster shot, but whether or not you get a booster shot does not determine your political party, right? So therefore, Democrats is the independent and getting a booster, or Republican, you know, the party affiliation really is the independent, and whether or not you get a booster shot is the dependent. Okay, second one, any questions about that first one? Okay, second one, older people who are Democrats are more likely to get a booster shot for COVID-19. And then I surmise older people who are Democrats are more likely to get a booster shot for the flu. Is that inductive or deductive? Say it again. Right, and the second one? Deduction, right? So the second one is deduction. And why? Why is it deduction? Yeah. Yeah, I give you a clue that I say I surmise. But also is that I have not actually observed whether or not older people who are Democrats are more likely to get the flu shot than yeah, I have not really observed that. Okay. Older people who are Democrats are more likely to get a booster shot for COVID-19. If I want to test this, what would my research question be and what would my null hypothesis be? Yeah. Usually, yeah. I mean, it's a good question because sometimes those terms are used interchangeably. Because oftentimes you can have a research question and then you state it as a hypothesis and then you state a null hypothesis. But typically when we talk about a research, when you actually form your research question, it is in the form of a hypothesis. I mean, the difference, like a research question could be, do Democrats or Republicans, are Democrats or Republicans more likely to get flu shots, right? That's a research question. Your hypothesis could be Democrats are more likely than Republicans to get flu shots. And so your null hypothesis is Democrats are no more likely than Republicans to get flu shots. Okay, so do you understand the difference between those things? So I mean, sometimes you can, because you can have a research, oftentimes when people talk about their research questions, they say, I think Democrats are going to be more likely to get flu shots, right? And they state, that's the research question really, but they're really stating a hypothesis. So if you wanted to break these things into different parts, you'd say, research question, does party affiliation determine likelihood of getting a flu shot? And that's such your research question, right? Your hypothesis could be that Democrats are more likely than Republicans to get a flu shot. And then your null hypothesis is Democrats are no more likely or not more likely than Republicans. Okay, is that clear? Okay. Older people or Democrats are more likely to get a booster for COVID-19. How do I operationalize these variables? So like, what does it mean? So how would you answer this question? Well, what variables do I have to operationalize? Okay, so somehow party affiliation, because I mean, even though I said this about Democrats, it really means you're talking about party affiliation, because your population is not just Democrats, right? Correct. I mean, like if I had said Democrats who are older are more likely than Democrats who are younger to get a flu shot, then what's my population? Democrats. If I say Democrats are more likely to get a booster shot for COVID-19, then what's my population? Which one? Everyone, right? Everyone, or at least older people. It could be all older people. So if I specify older people, then I'm implicit, because the question you have to ask is who am I comparing it to? Right. So in this case, if I'm, it's not stated in there, but the assumption being is that, oh, you're comparing it to Republicans, right? Because I could say, in my mind, I could be saying Democrats who are more likely to get a booster shot for COVID-19 than are aliens, right? In that case, then my population is Democrats and aliens. And and so that would be my sample would then be somewhat there. But if I'm talking about party affiliation, then Democrats versus Republicans, or at least independents and things like that. Okay, so how do I operationalize being a Democrat? Well, if you wanted to figure out who was Democrats, how would you do it? Yeah, ask them, right? You're a Democrat. What's your party affiliation? So then you find, and what does older mean? Careful now. What does older mean? Over, yeah. So pick an age, right? Over 50 or over 40, whatever it's going to be. Mhm. I mean, how would you determine what older means in this case? Well, it kind of depends on your theory. Like, why is it that you think that older people rather than younger people are going to get flu shots? And why would you think that older Democrats rather than older Republicans are going to get flu shots? So, okay. So you got Democrat, you have older. How would you get a likely booster shot for COVID-19? How would you operationalize that? Say that. Have you had a booster shot, right? So you could ask them, have you had a booster shot? You could ask them, do you intend to get a booster shot, right? So it could be intentions or it could be behavior. Either way, they're both ways operationalized. That's why with a lot of these questions, it's not like there's a right answer, but instead what I'm looking for is that, do you understand the concept of how to go through and operationalize something? Okay. So that's the type of questions that I'll ask in the first part. Any questions about that? Okay, so then I gave you an article. The article was the early findings from a survey on disruptions in care and outcomes for COVID-19 pandemic on persons with multiple sclerosis. So take this first question. Which group, minimal, mild, moderate, severely disabled, reported the worst health status? So it says to go here. So which one has, let's see, we'll go to the actual paper. Okay, so here's your self-reported health status below the sample average, right? So which group has the worst reported health status? A moderate disability, even though that's a higher number. Yeah, so what's the is this a dependent or an independent variable? What are the independent and dependent variables here? Like in this relationship between disability and self-reported health, what's the independent variable and what's the dependent variable? Well, if you do a factor 1 and factor 2, what leads to what? That's right. Disability status leads to health status. So therefore, disability status is the independent and health status is the dependent, right? So even though it's kind of, a little bit different because they put these things on top here, these are really independent variables. And so this then is these are all dependent variables going down there. But what is this dependent variable? Explain to me in words what this dependent variable is. Now here, go read, see if you can read this up here. And that's why good to read the article really, really carefully before, because if I ask you a question like this, then you're probably not going to have time to go through and read and try and figure it out. So it's best to read the article, and ask yourself, what are these variables as you go through this? What are these variables that they're reporting? Like not just kind of as a like, oh, they're reporting health stats, but like how exactly are they measuring? So in this case, if you read this paragraph here, any guesses? Or anyone want to take a stab?
I think so, but people who want to hear anything.
So what does this 78.2 mean?
I was wondering if they had some wondering if they talked about. And people outreach.
Right. Yeah.
So
So
it's just the cost, it's just the amount of people that were.
Right.
It's not that they had work.
that's right. So this is the percentage of people who reported that they were below the sample average, right? So what they did is they got a sample average, like so they got a sample of health status, and then they split this, they just figured out where the average was for people for health status. And then they looked at what percentage of people are below the average and above the average. Right. And so then they report it this way. So people with minimal disability, only 16.5% of them were below average. That means that 83.5% of them were above average or above the average. For mild disability, it was about 50-50, right? For moderate and severe, they were mostly below average. What's the sample size? Where would I figure out the sample size? Add up all these things, right? I mean, I'm sure they say it in here someplace. Right? They'll say in here what the total sample size was. Here it is. But basically it's the n, the denominator's n, right? That's the sample size. So you can see is that, most people in the sample, 1,343, had a minimal disability. And so 251 had a severe disability. Okay. So let's see, go back to the questions now. So that's the first question. Second one, which group mild reported the greatest fear that MS would get worse because they miss care? So we go back to this. Whoops. That again. Okay. Is there a variable here that says fear that MS might get worse because they miss care? Yeah, this one here. right? So which group had the greatest fear? This one over here, right? Severe 40.6 over there. So see, what I'm really doing is I'm just, having you go through and just read the tables. So if you had, so what I'm looking for in this case is like, can you go through and read the tables and interpret the table? Okay. Oh. Very good. So, the other ones are just, I'll let you go through those yourself. But then we'll go down to this last one. One of the limitations is that the cross-sectional study, you have to develop a longitudinal study that will address some of the same issues with some of the issues with the cross-sectional design. So, if you want to do a longitudinal study, then, what might you do? So remember, this is for COVID. And so if you want to do a longitudinal study with COVID, like how would you design a longitudinal study?
People who have recently developed COVID and all of them this time, and just keep serving them like not more than 5 years.
Okay.
Like so you would
Yep.
survey them, and then you would see how has COVID affected you have you gotten COVID.
Okay, so let's be specific. When would you start to survey them?
Once you got off have COVID.
Well, I mean, is this study about, are you only interested in people who have COVID, or you're interested in people with disability regardless of whether they have COVID or not? I mean, because the study is about, is impact of COVID-19 pandemic on persons with multiple, it's not impact of COVID. It's just the impact of the fact that there's a pandemic. Why might the pandemic influence, why might the fact that there's a pandemic influence people with disabilities, with multiple sclerosis? Is that better? Yeah, because everything closes down. So if you think, well, if everything closes down, and if all healthcare resources are being diverted to other places, then who's going to be impacted by this? Well, people who need ongoing healthcare. So people with multiple sclerosis, needs ongoing healthcare. So that's why they're interested in not just COVID per se, but about, what the impact is independent of COVID. So given that, then when should if you're going to, in retrospect now, if COVID just started and you were going to do a longitudinal survey, when would you start surveying people? Yes, as fast as possible, right? So before things get shut down, and then when would you do your next survey? Three months? I mean, because you could tie it to like something that happens, right? So we're going to do our first survey when the pandemic starts, and the second one when there's going to be a vaccination, something like that. You could tie it to some type of event like that. But what's more normal, more usual, I should say, with a longitudinal survey is you do it, through time periods. So like you do it now, baseline, then you do it 3 months, then 6 months, and then maybe a year. So you have some type of set time periods that you're going to do it in. Okay. So that's what I'm looking for in that. It's basically that you have some type of logic for when you're going to, that you thought out kind of, okay, when do I have to get these surveys? You could say that you want to do your study on the impact of COVID. And so you could then just sort of say, well, okay, we'll survey people when they get COVID and start there and see the impact of COVID. But how would you ensure there's a good response for your survey across time? So you can give out a survey. I mean, because the problem with longitudinal surveys is that it means that you got to keep, going back to people over and over again. How would you ensure that there's a good response?
Every single like survey after that.
Okay, so you can basically, I won't say pay them, but you can reward them for thank them for, and increasingly thank them for taking your surveys. Yep, you could do that. What else could you do? Well, I mean, why might people not take your survey after 3 months? It died, right? Could have moved, could have, just lost their telephone, something like that. So there could be different reasons. So sometimes what they do with surveys is that they contact people like every week, even though they're not going to survey them. They'll just call them up and say, hey, just making sure you're still there, because they know that the person, that way they can check to see if the person says, oh, by the way, I'm moving next week, is that then they know where they're going to move to. So that's one way to do it. So the sampling errors that might occur with your survey. With this type of survey, what's the sampling error? The sampling bias, I should say, that comes along. The type of biases come along with this type of sampling. Yeah, survivor bias, right? Is that people get lost. They don't show up at 3 months or 6 months or 9 months. And so that's the main type of a problem with a longitudinal survey. And so why does that lead to a problem? I mean, a bias in your survey? Let's say that if I gave a survey to all the class, and then I was going to give it every 3 months. And at the end of 2 months, aliens came and randomly took 5 people from class. And then I give the survey. And then after the next survey, aliens took 5 people from class. And so then, I give my final survey. So I'm down 10 people because aliens took you. Would my survey be biased? No, not if aliens just randomly selected you and took you away. It would not be biased. I mean, I would be, I'd have less people when it came down to 6 months down the road than at the start, but it wouldn't be a bias. Thankfully for me, it wouldn't be a biased survey because of it. So why, in this case, why might it be a bias? If you given to people with disability at baseline at 3 months, at 6 months, and there's less people, what might the potential bias be? So the question asked is, well, who's going to drop out? Like in my study, it was random because aliens just randomly selected you. But in this study, will it be random who drops out? Who's likely to drop out? People are probably the most seriously impacted. Like, the most extreme thing is that, people might die, right? So if they really didn't get any type of healthcare resources and they died, then that's sort of the ultimate dropout. So, that the idea is that, well, people who are the most able, most independent are going to be the ones who are more likely to stay in the survey. That's a bias. So with longitudinal surveys, the potential bias is the survivorship bias. And the reason it can be a bias is if the people who stay in the survey are different than the people who drop out of the survey. So why is this type of survey better than a randomized, than a cross-sectional survey? What can you do in the longitudinal survey that you have trouble doing in a cross-sectional survey? You have trouble in a cross-sectional survey showing rhymes with causality. Causality, right? You have trouble showing causality in a cross-sectional survey. You can show correlation, but not causality. So that's the problem with a cross-sectional survey. with a longitudinal survey, you're more likely to have causality. For example, the assumption here is that less healthcare leads to worse health status, right? That's the basic that's the basic assumption going here. So it's going to lead to worse health status. And so therefore you think that the causality goes is that less healthcare leads to worse health status. But it could also be people with worse health status have worse healthcare. And so if you do if you just do a causal, if you just do a cross-sectional study and you find there's a relationship between health status and the amount of resources you get, then you're going to assume that resources lead to health status, right? But it could also be that health status leads to resources. For example, let's say that you're going to the doctor, every week, but it didn't really matter. The doctor was just, coming in there and talking about football with you, so that it really didn't do you any good. But you're going every week, and suddenly your health status goes down, and you can't go to the doctor anymore. So it looks like, oh, this person's health status is poor, and they're not going to the doctor as much. But you don't know whether or not it's their health status is down because they stopped going to the doctor, or they couldn't go to the doctor, or their health status went down, and so as a result, they couldn't go to the doctor anymore. That's what I mean when I say that you don't know the causality. You can tell a correlation, but you can't do a causality. In a longitudinal study, you can tell the causality because you can look to see, well, here's someone's health status, here's their healthcare, their health, their use of healthcare. If their use of healthcare goes down, following that, does their health status go down? Okay. So that's the type of test. Any questions about that? Yeah.
So I still don't understand like induction because when I did this practice test, I thought that both of them were inductions, but the only difference I saw was that I noticed it. Like it came as a different question.
Yeah, and that's notice means that you've observed it. And it's like, so observe it, how they observe it. I was sitting in Rite Aid, waiting room, I just like to hang out in Rite Aid waiting room, and all these people came in, had Biden stickers on. And so I thought to myself, oh, I bet you, and they're all older. So I thought, oh, I bet you old people are more likely to go and get booster shots, get COVID booster shots, right? So that's my observation. And so from my observation, I induce a general rule. On the other hand, if I'm sitting there and I think to myself, what else what other kind of behaviors would be consistent with getting a COVID booster shot, right? So going to a Trump rally, they're probably not going to be more likely to do that. Probably less likely. Getting a flu vaccine, well, could be if they're likely to get a COVID, then maybe they're likely to get a flu vaccine. So what I'm doing is I'm using my knowledge of, I'm making the link between their behavior in this setting I can observe with other types of things as well. That's deduction, but I haven't observed it. I haven't actually seen whether or not people come in to get a booster shot. Get a flu vaccine. Other questions? All right. Well, good luck. Rudy, when are you having office hours? Tomorrow?
Okay, but, I'm review.
Okay. What time today?
5:30.
5:30 today. Okay, so Rudy's having office hours and a review. I'm having I have office hours today at 12. And then if you have any questions, just email me. I can respond by email. All right, see you here at 9.